Electrophoretic technology mimics the effect of ink on paper. The screens reflect light, unlike conventional backlit displays that emit light. Also known as e-paper, this technology has changed the way we see our screens. Mobile devices, e-readers, smartwatches, and credit cards all contain electrophoretic displays. With its print-like readability and Bluetooth capability, it's easy to see the attraction. To make an electrophoretic screen, polyethylene film is placed on a sheet of glass, which holds the film as it's processed. Production takes place in a filtered room to keep the area contaminant-free. Inside the room, robots move the glass carrier through processes that transform the film into the backplane. The backplane is the main structure of the screen. It carries the organic transistors that drive the electrophoretic display. Machinery builds up micro-thin layers of metal, organic solutions, semiconductors, and isolators. This spin coater evenly spreads the material across the film. Nozzles apply an organic solution that acts as a booster for the semiconductors. The spin coater closes and rotates the glass carrier to spread the deposited material by centrifugal force. The automated system adds layers of semiconductors, electrical isolators, and metal. A rinse of deionized water cleans the coated film, and a blast of air blows off the water. Rollers apply gentle pressure to ensure the film sticks to the glass, even when positioned vertically. Once the photoresist chemical has been applied, the film goes into an exposure chamber. A pattern mask is placed in front of the film to block out lighting in some areas. The exposure defines the structure of the metal layers, so that when combined with the other materials, they'll serve as transistors. The backplane film is removed from the glass carrier. Now the film is ready for the electronic ink sheet placement. A technician places the backplane in a laminator. He uses a camera to magnify and position the backplane. A vacuum in the laminator chuck pulls the backplane in place. He places the electronic ink sheet on the chuck beside the backplane and peels off the liner, exposing the adhesive. Then the ink sheet and the backplane are fused together. A roller presses the assembly for full adhesion. Once the lamination process is complete, a technician removes the screen from the chuck. This is the backplane before and after the electronic ink lamination. An automated system bonds the electronics to a circuit board that's attached to the display screen. The system mechanically seals the circuit board. Polymer resin is applied for stability. UV light cures the resin. This is the electrophoretic display before and after the electronics have been added. This particular display screen will be an e-reader. They load a graphic with black strips onto the screen. The strips serve as reference points as a printer applies a combination red, green, and blue filter. The filter adds the option of colored text or pictures. The primary colors can be combined to create other shades, expanding the visual possibilities of the electronic ink. A machine bends a sample screen repeatedly to confirm that the sample is flexible enough to be formed into a bracelet or credit card. Additional tests are conducted to confirm that the electrophoretic display has the desired clarity and color. Display patterns can be sent from a phone to a bracelet that has an electrophoretic screen. With electrophoretic technology, There are many different ways to enjoy screen time.